And now what I know you've been waiting for is a trig integral. So I brought my dog along because he loves trig. Woof! He can do the unit circle with both paws, like you should be able to. So we do the same rules. Integral of 2 is 2x. Integral of cosine is sine. Always worth checking to make sure that you have the correct sign in front of your trig function. The derivative of sine is cosine, so we're good. From pi down to 0. So subtract. So we have 2 pi plus the sine of pi minus 0 plus the sine of 0. So 2 pi plus the sine of pi, coordinates negative 1, 0, so the sine is 0, minus 0 minus the sine of 0, which is also 0. So your answer here is 2 pi. Actually pretty easy trig function. A lot of times they're easier to do because they're not as complicated until we get into undoing the chain rule trig problems. Woof. So now we have another trig function that we need to do, and we can't undo fractions. We don't have any rules for that yet, so we're going to need to change the form of our function. So since secant and tangent are related in Pythagorean identities, I want to see if I can substitute something here that would make this a monomial so we could divide. So start out with the regular Pythagorean identity, sine squared plus cosine squared equals 1. And we want to get a secant squared, so we want to divide by cosine squared over here. That gives us our secant squared. So if we're dividing by cosine squared there, we divide everything by cosine squared. Sine squared over cosine squared is tangent squared plus 1 equals secant squared. So we can look and direct substitute secant squared in for tangent squared plus 1. So we really have the integral from 0 to pi over 4 of secant squared over secant squared, which is just 1. Integral of 1, let's keep our variable. So theta from pi over 4 down to 0. So we have pi over 4 minus 0, which is just pi over 4. Again, the trig functions not so bad. Not that difficult to do if you're careful with your steps. About to start the game.